Hello and welcome to Science Never Stops. I'm your host Joseph Vick with the U.S. Space and Rocket Center, and today's topic is Play-Doh planets. So we're going to be creating our own planets out of Play-Doh and various other materials, but I wanted to tell you about the type of planet we're going to be making. We're going to be making terrestrial planets. Now there are 4 terrestrial planets in our solar system. Now the first happens to be the first planet, planet Mercury, which you can see here. It's closest to the sun and characterized with the grayish coloration, the multiple craterous zones and spots, and looks similar to our moon almost if you look at it. The next is Venus, another terrestrial rocky planet. Venus is our sister planet, close in size, and you can also see it really early in the morning when you have that very bright Venus star in the morning. It's very bright in the night sky and morning sky. Our own planet, planet Earth, a terrestrial planet, not only terrestrial with land, but with water, liquid water, or water in all 3 phases, solid, liquid, and gas. And Mars, where we are destined to look. We have robots on currently, and will hopefully have astronauts walking on the surface as well. These are the 4 main rocky planets, or terrestrial planets, in our solar system that we have and we can focus on when we're looking at building our very own type of planet. Now, those are planets within our solar system. Scientists also discover planets outside of our solar system that are also rocky in nature, exoplanets, with various features, or super Earths, and they're also very unique planets with hard surfaces. And with hard surfaces you can have life, or you can have water within that hard surface. So let's look and see what a planet is made of. Alright, what are planets made of? So easiest way to do this is you can get a sheet of paper, or in your journal you can draw a large circle. I used circular stencil here and traced it with a pencil on my sheet of paper, or you could do this directly in your journal, but I was going to use some paint. You can also use markers or crayons, pencils, whatever you think is best or you like working with the most, to show the different layers on the inside of a planet. A planet is spherical, which means gravity is pushing everything to the center, making it round or spherical shaped. And with that spherical shape, all of that gravity is pulling in, and the inside of the planet is much hotter than the outside. Now, there are 3 main sections, or 3 main layers to a planet. And since these layers are sort of stacked on top of each other, they're also blended with one another. If you cut open a planet, like I have an example here, planet Apple, if I were to cut open, there we go, and you would have the various parts and layers of this apple. You would have the outer skin of the apple, that very thin layer that we're looking at, the major meat of the apple, which is the thickest part of the apple, the part that we really like to eat and enjoy, on into that center core of the apple, the outer core, and then that inner core where we have the seeds located. So layers of planets are very similar to layers of apples, and it's a nice tasty treat to have after this activity. Now, I have here water. I have my watercolor paints. Again, you can use I'll use this brush, your markers, your crayons, whatever you like best. Also, I have various colors of Play-Doh that I'm going to use to make an example of what we're painting. So the first layer is the crust. The crust is the crusty layer, very much like the skin of the apple or a crusty piece of bread on a pizza. That's that crusty hard layer on that surface. And that is a very thin layer, just like the layer that we saw there on the apple. So I'm going to trace a really thin layer of brown around the surface. So the crust is where we currently live on the surface of the Earth. It's where you can dig down, and layers of the Earth over time have built up, and that is the crust. Now, underneath the crust, you have what's called the mantle. Now, the mantle is the thickest layer of the Earth, very similar to what we saw with the apple. It's the meat of the apple. Now, unlike the apple, the meat of the apple is hard. Think the mantle is sort of a semi-solid. It is a semi-solid, and it is sort of gelatinous. It is a gel-type magma layer. I say magma and not lava because magma resides within the Earth, and it's lava once it emerges out of a volcano. It again is the thickest layer, and it's what the crust rides on top of. Like a slow-moving gel. Also, it's what moves layers of the crust around, called plate tectonics. That layer of really hot molten rock in the mantle acts as sort of a moving gel that crust moves across. Now notice I'm sort of swaying around and moving it around. There's not really defined layers. If you were going to cut the Earth open, just like we cut that apple open, you wouldn't have a defined layer. You'd go, that is where the crust ends, that's where the mantle starts. It transitions slowly one layer into the other. So that's why I'm blending it here with the paint. And then we have the core in the very center. Just like the apple, there's the outer core. The outer core here. And then we have in the very center the inner core. Now on Earth, these are metals, and those metals in the core help with our direction, with north and how a compass can work. I'll make the inner core a little bit darker. There we go. So we start where we live, there on the crust, that very thin rocky layer, moving into that gelatinous mantle area where the crust floats and moves on top of. Going a little bit further, getting hotter each way we go in to the center of the Earth, to the outer core, and then to the very, very center, the inner core. And these are the main planet layers. Now we had just painted our layers of our planet, and each of those layers, the crust, the mantle, and the core, can be also represented in a three-dimensional manner with Play-Doh. So I'm going to first add my layer, the thin layer called the crust. I have here old Christmas ornament that separates. You can also use a bowl to do this, to line the bowl. So with the crust, it's a very thin layer of the planet. So squish that Play-Doh down as thin and stretch that crust Play-Doh material as far as you can. If you can see through it in areas, that's even better. On planet Earth, there are much thicker regions of the crust and much thicker regions of the crust. That includes where we stand, as well as deep within the depths of the ocean, the oceanic trenches down below. And stretch that along the inside of this ornament piece. Now the clear piece can also represent the atmosphere, as it is the crust that interacts directly with the atmospheres of the Earth. There we go. Nice layer of crust there, and you can see the crust here on the other side. Next is that thickest layer of the planet, which is, like I mentioned, that gelatinous mantle, which is that magma layer. So that one's going to be thicker, so I'm going to put that big blob there in the center. Keep adding layers and layers of mantle. And the mantle actually would, if you could touch it, because it is magma and it would melt your hands off, but it would feel very similar or move very fluidly but still solid like this Play-Doh is in your hand. And it's that movement and that flowing nature of the mantle that moves the crust around the earth. And as you're pressing down and moving this, you may have that crust start to move up and out and around the outside. That's great. That is exactly what the mantle does with the crust layer on the surface of the earth. It moves it around. So there we go. There's the large chunk of the mantle. And then there is a large solid core in the middle. I used a marble there, solid metal core there in the center. Put that right there. And we have our Play-Doh planet. Now, that's an example of a planet. Now, we learned the layers, but what about the crust? What about the features on the surface that make a planet unique? Use your artistic skill and talent. I did, and I drew out my planet called Play-Doh Planet, which I describe it as a place of adventure, a place of exploration, a place where purple-orange trees grow on top of a floating red clouds, where a large sloths sing like birds every morning when it rains strawberries. So that's a little over the top, but in your journal, as you are an astronomer looking out and looking up and discovering new planets and new features of the cosmos, you too can be creative. It takes creativity to be any type of scientist. So in your journal, draw out what your type of planet would look like on the surface. And then also in your journal, describe and write out what your ideas would be if you could explore the surface of that planet, even if it may be a robotic exploration or just a flyby. Which type of technology would you use to explore your planet? So, enjoy being creative, enjoy doing science, and remember, just like being creative, also science never stops.